this is our third lab about fast, reliable file transfer. Okay, first let me introduce our project. So this project uses UDP socket programming to transfer large files between client and server reliably. We know that UDP is a protocol that doesn't respond for reliability. To overcome it, we implemented a sequence number and several different signals to distinguish requests for respective purpose. Other than basic reliability, we try to make our project stable even in higher loss and delay situations. First, let's see how we use UDP. We have to give both client and server side the port number we are going to use. And we also have to give the server's IP address to client. Both client and server create datagram socket. Other than that, server needs to bend the socket and then wait for connection. But it's not necessary for client. Client just need to put all information about server into socket address structure and then use it when send or receive packets. Using UDP has advantages like we don't need to handshake, make it easier and faster to transfer data than TCP. But on the other hand, we can see the disadvantage directly, like we can guarantee no loss during data exchange like TCP. So what we are going to do in this lab is to make sure our program don't lose packets during transfer. Here's something we did to make it reliable. First, packets with sequence number and type. When we declare packet structure, we claim 4 parameters: packet data size, packet sequence, packet type, and packet data. Before I explain these 4 parameters, I have to notice you that we cut the file we are going to transfer into small pieces and give each piece its own number. So the packet sequence is like to record that number of each small pieces, and packet data contain the data of each pieces. Data size is like the total size of the data packet data. And the second thing we did is record packets number after we segment the target file. So here the packets number means the total pieces we have cut the file into. Using receive header and send header functions to make sure both sender and receive acknowledge that how many packets they are going to transfer. And the third thing is about the packet type. We will depend on packet type to acknowledge what kind of data we are receiving right now or what we are sending right now, and decide what to do next step. The fourth thing we did is for each acknowledged type packets, we send it at most 200 times to make sure these important acknowledged packets don't lose. And the fifth thing we did is for data packets, we send it at most 20 times to reduce the possibility of losing. So here's something we did before we transfer the file. At first, the client will send the request packets to the server, and there's 3 kinds of request packets. They're download, upload, and message. After the server receives this request, it will send back the acknowledged packets for them respectively. For the download request, after the server sends back the acknowledge, it will wait for download file request from the client. After the server receives that request, it will see if the file is accessible in this device, and if the file is accessible, it will send a download file request acknowledge, calculate the total frame to be sent, and step into the sender process. For the upload request, the sender will send back the acknowledge and then step into receive process. And for the message request, the server will send back the acknowledge and keep waiting for other requests to tell him what to do next. And here's the sender process, and here's the receiver process. We will look into the sender process first. At first, the sender will send the header request tab packets that will include the information about the total frame we are going to exchange in this transfer. And he will wait for the receiver to send back the request acknowledge. After we receive that, we can send file in separate packets at one time in send tab packets. After we send all the packets, we can send the send file down tab packets to acknowledge other side. We have finished sending all the packets. After that, we will waiting in the line, waiting for the send file down acknowledge from the receiver side. If we receive that signal, that means the receiver side know that the first total send has been finished, and then we will wait for the receiver to check if they have received all the packets they need, like we described in the header request. And if the receiver have received all the packets they need, they will send a get all file signal for the sender. And if the sender received that signal, that means they have finished. So the sender will send back the get all file acknowledge back to the receiver, and that's it. We have finished. But if we can't receive the sender file down acknowledge from the receiver at this step, that means maybe the receiver can't receive the send file down signal from us. So we have to resend that like 200 times. So at this step, if we can't receive the get all file signal, that means the receiver are missing some packets. In that case, the receiver will send us the information about the missing packets number. In that case, what the sender do is listening, waiting until we receive the send missing down signal. That means the receiver has sent all the missing packets information for us. They have finished send the information. So after that, we will send back the acknowledge. That means we receive all the missing packets information from you. And after that, we will send back missing packets to receiver. After we send back, we will send file down signal. So we will back to this step, and we will repeat all the steps again and again until we can get all file acknowledged information. So that's the sender process. For the receiver process, first it will receive a header in request tab of packet in request tab. That means it will include the information about how many frames the receiver are going to receive, and the receiver will send back the request acknowledge to the sender. And after that, the receiver will listening, waiting for the packets from the sender. And once we receive the send file down signal from the sender, that means they have finished send all the packets. In that case, we will go down to send back the acknowledge about the send file down. And if we can't receive the send file down signal, that means we are still receiving the data information, not the signal. So what we have to do is to save this data we have received and record the received sequence number. So after we receive that signal, we'll send back the acknowledge, and then we will check if we have all the packets we need. And if we are missing something, in that case, we will go to this part. If we are missing something, we will send the missing packets in send missing tab. So in this tab of package, we will send the information about the sequence number we are missing. After we send out the missing information, we will send the send missing down information to the sender. And after that, we will waiting for their information and until we receive the send missing down acknowledge from the sender. If they don't send back the acknowledge, that means maybe they don't receive the send missing down signal. So we have to resend that again and again until we receive the send missing down acknowledge. After that, we will wait for the send file down signal again. So we finish one loop and go into another loop until we get the send file down acknowledge and go to this step to check if we have packets to resend. If we don't have packets to resend, that means we receive all the data we need. In that case, we will send the get all file signal to the sender. After that, we will wait for the get all file acknowledge from the sender. If we can't receive that signal, we have to resend our get all file signal to sender again and again until we get the back acknowledge. After that, that's it, we finish. After all the send and receive process finish, we will put the received data into file. We have saved file data into a map structure which correspond packet sequence number and data to be written in the file. Now that what we need to do is write this data into target file sequentially. After that, we will use empty file to check if the original file and received file are same. Here's some results we have got. In the situation we have no loss and delay, here's the result. The time of the first scan frame is at 14 seconds, and the last time of getting the last frame is 25, and time of getting the last missing frame is 26. That means we don't lose a lot of packets, and the average rate is 116.67 Mbps. In the situation, we have 10 milliseconds delay and 1% loss. We can see the time we send the first frame is 45 seconds, and getting the last frame is 56. Getting the last missing frame is 57. It's not a big difference, so we can see we don't lose a lot, and the average rate is 116.67 Mbps. But in the situation of 200 megaseconds delay and 20% loss, we can see the send first frame time is 7 and get the last frame time is 18, but get the last missing frame time is the next minute 16 seconds. So in this situation, we can see that we lost a lot of packets, so we have to resend again and again. So that makes the total rates get down a lot. We get 20.29 Mbps in this situation. So the limitation for the program is that it can't transfer the data reliably when there are some characters can be converted into string type. And from the result we get from in 3 different situations, we can see UDP is not reliable and can't provide congestion control. Therefore, when using UDP to transfer file, the most important thing to do is that having a retransmission process to request the missing frames in the file. In addition, some acknowledgements must be sent multiple times to make sure client or server receive them. So the retransfer formation process is like we said, 20 times resend for the data packets, and this part is like we set the 200 times to resend the acknowledged information. So that's it. That's our lab 3. Here's the server side demo. So here's the client side demo.